Okay, so remember, the standard error for just y hat is s over the square root of n. Okay, so if I square that, I get s squared over n. But what is s squared? It is the variance. So I'm going to write this as 7.036 squared divided by n, which is 23, plus, okay, 7.772 squared divided by n, which is 22. Now, you could have just written this as the 49.5 and the 60.4 because I already knew the variance. Okay, so there is the standard error. All right, let's get my calculator out here. Okay, so 7.036 squared takes me back to the 49.5, okay, divided by 23 plus 7.772 squared divided by 22 okay, and I get 4.898. Okay, and then the square root of that, second square root of 4.898, 2.21. Okay, so that is 2.21. So my t-score is 1.8 divided by 2.21 is 0.8144. Okay. Okay, now I'm going to erase the standard error here just so I've got room to work. Okay. All we have to do now is change this 0.1844 into a p-value. So with the p-value for t, okay, we'll talk about degrees of freedom, greater than 0.8144. Okay, that is TCDF from 0.8144 to 10 with how many degrees of freedom. Okay, this is what puts us a little bit of in a bind. Okay, the only way to calculate the true degrees of freedom is to actually do this problem on your calculator. Okay, and so that means type this in, do a 2-sample t-test on your calculator. Okay, it gives you all the answers and it gives you the degrees freedom. Okay, so I'm not going to do that first. Okay, here is a shortcut, close way to find the degrees of freedom. Okay, so it's 23 plus 22 minus 2. Okay, so instead of n minus 1, okay, it's going to be n minus 1 plus n minus 1. Okay, so that is 45 minus 2. Okay, and that is 43. So we're going to use 43 just as a quick shortcut. Okay. All right, now it's just on our calculator. So we're going to go second distribution. Okay, TCDF is number 6. My lower bound is 0.8144. Upper bound is 10. Degrees freedom is 43. So my p-value is 0.20995. Okay, there are about 4 of you that are continually making the wrong conclusion, which, to be honest with you, I can't understand why, because we've been doing the same thing now for 6 weeks, okay? Because of the extremely large p-value, because it's bigger than 0.05, okay, we fail to reject the null hypothesis. Okay, I have statistical evidence that there is no difference in average scores between the two classes. Okay, and if I want to take it a step further, I have no evidence for all the students in these 18 classes that there is no difference between their scores, whether they got to use a calculator or didn't get to use a calculator. Okay, if that number is less than 0.05, that means it's too far away and you reject the null and accept the alternative. So those 4 or 5 of you that keep making that mistake have got to stop. That's a fundamental thing, okay? Because of the large p-value, okay? That means it's not very far away. We fail to reject the null hypothesis. All right, so right now, Charlie's having a fit because of this 43, okay? The degrees freedom really isn't 43, okay? It's really close to 43, but it's not really 43. So we're gonna have to pull a fast one, Charlie, to find the true degrees of freedom. So we're gonna go to stat, test, okay? I'm gonna go to 2-sample t-test, okay? That's number 4, okay? So we wanna import the stats, not the raw data. All right, so what's my first mean, okay? So that's with the calculator. So that's 80 point what? 80.7. What is the standard deviation? 7.036. Okay, and then how many were there? 23. Okay, the second one, the mean is 78.9. Okay, its standard deviation is 7.772. Okay, and it has 22. Okay, and then I want U1, okay, to be greater than U2. Okay, so I think that's the last one. And then pooled, we're always going to put no. Okay, calculate. All right, hello, there's my t-value. Okay, my p-value is a little different, but it's really close. And what is the degrees freedom, Charlie? It's 42.12. So the degrees freedom is really 42.12. All right, and so if we run our calculation again, okay, and now it gives us our p-value is now you have to run it again. I've got the answer on my calculator. The p-value is 0.2103. Did that really change the problem? Okay, and they have yet to give a problem on the AP exam where it would have made a difference if you use 43 or if you use 42.12. Okay, here's what happens on the AP test. That p-value is so much bigger than 0.05 that no matter what alpha level I would have used, I am going to fail to reject the null hypothesis. Okay, so historically, you either get a really big p-value or you get a really, really small p-value, and there's no choice but to reject the null hypothesis and accept the alternative one, regardless of what alpha level that you use. Okay, they've been known to give you the 2 different alpha levels and the 2 different p-values and ask you what's the correct interpretation, but on a problem from scratch, then they don't even make it close. Okay, so you've got 4 or 5 more problems to do. Okay, so I've worked it out step by step by step. Okay, the things you don't see, I did not write out the conditions, actually write them out, and I have not written out the conclusion. I said it 2 or 3 times. Because of the large p-value, we fail to reject the null hypothesis. I have statistical evidence that there is no difference in average scores between the group that used the calculator and the group that did not use the calculator. Okay, so enjoy your Easter weekend. Okay, get this done for me, get it turned in. Okay, we'll have a quiz next week. Okay, we'll have one more chapter to do, and I'll decide how we're going to do the Unit 7 test, and then we are done. Actually, be the unit, I think Unit 7, whichever one it is. Okay, and then we'll start reviewing. Okay, so have a good break. See you on Wednesday. Bye.